Linux Security Part 2. In this nugget, we're going to talk about TCP wrappers, which allow us to restrict access to all the services on our system with just a couple of configuration files. Then we'll talk about PAM, which has to do with authentication for services on our system. And finally, we'll cover firewalls, and specifically IP tables, which is the firewall command used in the 2.4 kernel. Let's get to work. All right, well, let's begin by talking about TCP wrappers. Now, TCP wrappers allow or deny access to all the ZynetD applications sort of in one fell swoop. Okay? Basically, there's two files out there in the etc directory. One's called host.allow, and the other one's called host.deny. And you can specify in these files which hosts are allowed access to your system and which hosts are denied access to your system. Okay, that seems pretty intuitive by the names. But you can also restrict, which services particular hosts can access and so on. All right. So basically, what happens is ZynetD is out there listening for certain traffic on the various ports of the services that it's managing. Okay, and it gets some request. Well, the first thing that it does is it passes control over to TCP wrappers, and TCP wrappers then the thing it does is it looks for a match found in host.allow. If it finds a match in host.allow, it tells Zynet that yes, access is granted. Go ahead, grant them access. Go about your business. Okay. If no matches are found in host.allow, then it goes down to host.deny. Okay, so if it finds a match there, then it tells Zynet that actually access is denied and refuse access to this particular request. And if it doesn't find matches in either one, then TCP wrapper says, okay, access is granted, control is passed back to you, and then Zynet takes over. Okay, so instead of doing it like we did in the last video, where you can control what ZynetD does for various applications in, on an application by application basis, here you can kind of do it all at once. Okay, and now what we're going to do is look at the format of those files, the etc host.allow and the host.deny files. Okay, so each line in each one of these files has a list, okay, a daemon list, followed by a colon, followed by a client list. So let's go over some examples of the kinds of things that you can write in either of these files and talk about what they mean. Okay, so I can say all colon all. What does that do? Well, in host.allow, that allows access to all of the services from all clients. Okay, in host.deny, that would have the exact opposite effect. It would deny access to all of the daemons, all of the services for all of the clients. Okay, now remember though that host.allow is always checked first. So if in host.allow, we allow access to some daemon for some particular client, then that client is passed along and says, okay, access is granted, even if it says all colon all in host.deny. So always remember this little setup here, right? That host.allow is checked first, and if it finds access, it's granted. It doesn't check host.deny at all then. Okay, so you always have to remember that when you're setting these things up. All right, another example here is saying all colon.cbtnuggets.com. All right, well, in host.allow, this would say allow access to all of the services for any client in the cbtnuggets.com domain. All right, here we're saying allow access to the telnet service for all clients except those at xyz.com. Okay, so you can see the use of the keyword except here. You can also use the keyword except on the other side of the colon. So I could say, okay, xyz.com has access to all services on my system except for telnet. All right? And then the other way that you can specify, instead of saying like .xyz.com or .cbtnuggets.com, you can specify it this way with the IP address and the net mask. Okay, so here what we're saying is we're allowing access to all services for IP addresses 175.183.14. whatever. Okay, 1 up to 255. That's what this net mask says here. All right, so that's the basic gist of how host.allow and host.deny works, and that works in combination with ZynetD and the kinds of things we learned in the last video. All right, well, now let's move on and talk about PAM, which are pluggable authentication modules. We'll talk about what PAM is, why you would use it. We'll talk about how to configure PAM too, and then we'll move out to the Linux screen and actually look at some of this stuff firsthand. Okay, so what is PAM? PAM is a suite of shared libraries that enable the system administrator to choose how various applications perform authentication. All right, why would you use PAM? Well, you would use PAM because it allows you to upgrade the authentication mechanism without touching the application. All right, so let's do a little bit of history here to make all this make sense. All right, back in the day, back in like the 70s or even the 80s when I started using Unix, password management or password authentication was done in this one particular way. Okay, and I don't want to go into all the details of how it was done, but it was done. You typed in your password. It was done. It was shifted around with this special salt thing that they had in your password file. Blah blah blah. It was encrypted, and then you looked at the encrypted password in the etc password file to determine if somebody could log in. Well, that process of using the salt to shift around the numbers and then doing this encryption, that whole process was deemed to be lame. Okay, that it's not all that secure. People figured out ways to break it. Okay, and so what we had to do, right, what people had to do was they had to go in and mess with the application itself, the login application. Okay, so there was some code there, some C code or whatever, that governed the login process. And that code had to be rewritten because we just wanted to change the authentication mechanism. All right. Well, what PAM is allowing us to do is it's allowing us to separate those two. Okay. There's going to be the application and there's going to be the authentication mechanism, but they're different. We just are plugging in the authentication module for some particular application. All right. So, okay, so that's what PAM is doing. It allows us to separate those two so the applications can live out there. We don't have to go in and mess with the source code and recompile the application if we want to change how we're doing authentication for that particular application. All right. So let's look at some configuration options for PAM. All right, well, each file in this directory called /etc/pam.d corresponds to a PAM-aware application. Sort of the same way we looked at for Zynet, right? There was the zinetd.d directory, okay? And each file in that directory allowed us to configure some service that Zynet controlled. All right, and it's kind of the same way here. There's going to be all these different files, and each file governs a particular application. All right, now there are 4 different types of PAM modules. All right, and this will make more sense when we go out to the Linux screen and actually look at this firsthand. But for right now, let's just go through this, and like I said, it'll make more sense in a little bit. All right, there are 4 different types of PAM modules. There's authentication management, account management, session management, and password management. All right, authentication management is responsible for establishing the identity of some particular user. Okay. So for right now, we think of establishing your identity. How do you do that on a computer? You type in a password. Maybe one day that will be deemed to be lame again, right? That somebody will come up with a way to actually break into accounts, based on guessing passwords, or they'll be able to break the encrypted password in the /etc password file or something like that, and then we'll have to have a new way to establish identity. All right. Maybe in the future it's going to require a retina scan or a fingerprint or a speech recognition thing or something like that. Okay. And so we'll just be able to plug in a new authentication scheme, and we won't have to rewrite any of the applications. Okay. I hope this is starting to make sense now. All right. Then there's the account management module. All right. This is responsible for account management that doesn't have to do with authentication. All right, so perhaps there's some application out here that you're trying to gain access to, and you've typed in your password or whatever, and you established your identity. But there could be other rules. Even if you are a certain person that normally has access to this application, maybe it's outside of business hours, and we don't allow access to this application after 5 p.m. or something. Okay, so these are non-authentication based ways that we're controlling access to the accounts, to that particular application. All right, then there's session management. This controls the kinds of things that I do before I grant you access and after I grant you access to some particular application. Okay, so maybe before I grant you access to some application, I do some logging to say, yes, I'm granting access to them. Afterwards, maybe I do some logging saying how long you spent on the application, or what kinds of things you did while you were logged on to that application, and so on. Okay, and then there's password management, which has to do with like password policies. Things like how many times do you get to try to log into some user and fail before something happens, before the console's reset, or before we print out some warning message in some log file or something like that. Okay, so those are the 4 types of PAM modules. Let's move out to the Linux screen and look through this directory and gain a deeper understanding of how PAM works. All right, well, you can see here that I'm in the etc pam.d directory. Okay, and if I do a listing in this directory, you're going to see a whole bunch of files here, and each one relates to a PAM-aware application. So you can see the SU program, the sudo program, the login program, all these Red Hat config programs, and so on. Okay, these are all controlled. The authentication of all of these programs is controlled by PAM. All right, so let's look at one of these particular files. Let's just look at the login file. And the structure of this file is the same as the structure of all these other files. Okay, each line contains 3 fields. The first field is the module type, and we just talked about the 4 module types for PAM. Authentication, which is represented by AUTH, account, password, and session management. Okay. The next field here are control flags. The 4 valid values for control flags are required, requisite, sufficient, and optional. Okay, so that's the 4 different control flags we can use. And then this last field here is the module path. So this is the path to the shared library. All right. Now, okay, so let's talk about this in a little bit abstract terms. This is some test that you have to pass. Okay, what is this test? What is PAM secureTTY.so? What does this mean? We'll talk about that in a minute. But for right now, let's just talk about this as a test that you have to pass. It's required that you pass it, meaning that if you fail this test, you will not be granted access to the thing that login grants you access to, which is the shell. Okay, you will not be granted access to the shell if you fail this test. All right, that's part of the authentication mechanism for the login process. All right. If this said requisite, what this would mean is that, again, if you fail this test, you're not going to gain access to the shell. All right. But requisite is even stronger in that if you fail this test, none of the other tests are even going to be performed. All right, so it's in some sense it's a stronger version of required. What's the difference practically? Well, if it's requisite, maybe you're not even going. If this is so important that this test gets passed, that you don't even want to test these other things. Maybe like the next test or the next things that would happen is you'd prompt for a username and a password. Okay, but if you don't allow remote logins to your particular system or something, then when somebody tries to get into your system remotely, you just fail immediately, and you don't even let them type in a username and a password. And maybe the reason you don't do that is so that people can't be like packet sniffing for valid usernames on your system, and then they can like break in your building and get onto your computers or something. Okay, so you see what I'm trying to get at? That requisite doesn't even go on with the rest of the test. Required will go on with the rest of the tests, and so you need to evaluate for certain circumstances, and I'll show you a manual later that'll help you evaluate that, but you need to evaluate for certain circumstances whether you should be using requisite or required. Basically, the end result is kind of the same from the user's perspective. Okay, they are denied access to the shell. All right, so if it says required, you have to pass that test to go on. If it says sufficient here, then that means if you pass this test and this said sufficient, that would mean that you have sufficient privileges to access the shell. All right, and I don't even have to do any more tests. And then optional, basically just, it doesn't matter. Okay, the test is done, but it doesn't matter whether you pass or fail this test. If you've passed everything else up until this point, then you're going to be granted access to the shell. All right, so that's the 4 things: requisite, required, sufficient, and optional. All right, now let's talk about what these various things mean, these tests that you have to pass. So let's take a look and understand what the libsecurity PAM secureTTY.so module, what it actually does. So what we're going to do here is we're going to go over to this other shell window, and you can see the working directory I'm in for that shell. It's called user share doc / the PAM with the version that of PAM that I'm using /txts. Okay. Now inside of this directory are a bunch of README files, and there's a README file here for each of the modules that you can use with PAM. The one that we were talking about there was PAM_secureTTY. Okay, just to refresh your memory, let's go back to this window, and you can see it's PAM secureTTY. All right, so that's the file that we want to read. All right, so what I'm going to do here is I'm going to say more readme.pam/secureTTY. Okay, and this is going to tell us what the secureTTY library does for us, what that module does for us. So what it says is it allows root logins only if the user is logging in on a secure terminal. What's a secure terminal? Well, it's defined by the listing in /etc/secureTTY. Okay? It also makes sure that etc secure TTY is a plain file and is not world writable. It makes sure it's not world writable so that, you know, I couldn't go in there beforehand, put in my terminal that I'm trying to log in on as root, and, you know, gain access to the system that way. Okay, so we're only talking about root logins here, and we're only allowing root logins for terminals that are listed as secure. Okay, now going back to this other window, you can see that that particular module, okay, that test, in other words, is required. All right, so if this is not met, then you will not be gained access to the shell. All right, and notice this module only had to do with root logins. So if you were trying to log in as someone other than root, then it's not an issue, okay, and you're going to pass this test. But if you're trying to log in as root from a non-secure terminal, you're going to fail this test. All right, so you know, this is like a series of doors or series of hoops that you have to pass through. Okay, and if you pass through one, great, but then you still have to pass through this one because this one is also required. You can go and read in the particular directory that we were just in. You can go read what this one does. Okay, now some of the descriptions for these libraries and these modules are a little bit convoluted, especially the ones that have to do with stack, because what ends up happening is you know, the output, whether you pass this test or not, you know, it actually is deferred until you know, it calls some other thing and determines whether you pass that, and if you pass that, then you'll pass this test, and so on. So there's a little bit of a convoluted process here, but this is the kinds of things that PAM can do for you. This is the kinds of ways that you would learn about how to deal with PAM and what kinds of modules are out there for you to use. If we go to another workspace here, I've got a file open here that is the PAM Administrator's Reference Manual. And you can see here the System Administrator's Guide for PAM, and it's got, you know, all sorts of information in it. It's got all about the Linux PAM configuration files, okay, that we were just looking at. It's got a reference guide for all the available modules and when you would use them and that sort of thing, okay? And then it's got some other stuff down at the bottom like bugs and omissions and things like that, okay? So if you need more help with PAM, if you want to learn more about the various modules, you know that you can poke around in that directory that I was just showing you, the etc or the user share doc PAMs there, you know, /texts directory, and you can look at the administrator's guide to learn more about PAM as well. All right, well, now let's talk a little bit about firewall policies. A firewall is what sits between your internal network and the outside world. Okay, so all the information that comes into your internal network from the internet goes through your firewall, and similarly all the information that leaves your internal network and goes out onto the internet also goes through your firewall. And firewalls filter information on a packet-by-packet basis. Okay, so remember that anything that you transmit over the internet, whether it's an email message or some file or whatever, anything that you transmit over the internet gets broken up into these things called packets, and these packets all have the same size. Okay, and what's inside the packet is, you know, a piece of that file that you're transferring, a piece of that file that you're transferring, another piece of that file you're transferring, okay? But there's also some header information in each packet. And the header information that's in each packet is things like the source address, the type of data that's down here in the main part of the packet, the destination address, okay? And this just helps routers out in the internet, you know, determine where to send the packet so it can get to the destination, and it also helps on the other end in reassembling the packets. Okay? There's different commands in the history of Linux that you can use for firewall administration. One is ipfwadm, and this was used in Linux kernel 2.0. IP chains was used in Linux kernel 2.2, and now IP tables is what we use in Linux kernel 2.4. IP chains is still supported in kernel 2.4, but if you're running 2.4, there's no reason why you shouldn't be updating to IP tables, because it is a new and more secure firewall system. Okay, so let's look at the IP tables command. All right, and this is how you add rules to the IP tables firewall so that you can filter more things or whatever, and just change the way the firewall behaves. Okay, so this is the command, and then I've broken down what each piece is down here, what all the different options for each piece is. Okay, so the first part is -t table. So what table are you going to refer to? By default, it refers to the filter table. Okay, so you're just packet filtering, or you're filtering packets is what we say, meaning that you're weeding out packets that you don't want to come to your particular network for whatever reason. Okay, NAT and mangle are two other choices for table. NAT is when packets are establishing a new connection. That's the table you would refer to. Mangle is if you're going to alter packets. That's the table you should refer to for that. We're just going to focus on filtering packets. Okay, then the actions that you can take are minus capital A for append, minus D for delete, L for list, or F for flush. Okay, so basically what we're saying here is we're going to have this whole table of rules. And whenever we execute one of these commands, if we say minus A for the action, then that's going to append this rule onto all the existing rules that we've already created. If I want to delete a particular rule, then I use the minus capital D option, and I specify the rule that I want to delete. I can also just list my rules, or I can flush all of the rules. Now, for certain actions like append and delete, you're giving a particular direction that you're talking about. Okay, so you're saying for packets that are coming into my system, for packets that are leaving my system, or for packets that are going through my system in some forwarding capability. Okay, so some firewalls, might see a packet, or some router might see a packet, and it's just destined to be forwarded through the router. It's not actually coming to your internal network. It's just using your thing as sort of a hop to get to the next place. Okay, the packet pattern, we can say minus lowercase s followed by some IP address to look for packets that are coming from some particular source IP address. Okay, we can also filter out packets based on its destination address. Okay, and there's other rules here too that you can look up in the man pages for IP tables. Okay, and then fate is what you do with the packet once it matches some pattern and it's followed along, and it's in the right direction and everything like that. Okay, do you drop the packet, do you accept the packet, or do you reject the packet? Okay, so let's just look at some examples of some rules, some IP tables rules. So here I can say IP tables minus A input, minus S this IP address, minus J drop. So what this is saying is packets that are coming to my system from this source IP address, I want to drop. Okay, so that's what's going to happen to the packets coming from that IP address if they're destined for my particular local network. Okay, here what I'm saying is minus A forward, minus J drop. So this is saying I'm filtering out all packets that I would just forward. I'm just going to drop those packets. I'm not going to act as a forwarding box for some other router. Okay, and then this one here is IP tables minus D, so I'm deleting some rule, and the rule that I'm deleting is this one that I created up here. So here I give the exact same specifications that I gave up there, except I use the minus D option instead of the minus A option, and that would delete that rule from my tables, from my list of options of which I'm filtering packets. Alright, well, it's time to wrap up our second nugget on Linux security, and this is actually the last video in the series, and we're going to wrap up the whole series too. So we started this nugget by talking about TCP wrappers. Now, TCP wrappers gave us a way to allow or deny access to services on our system using the host.allow and host.deny files in the etc directory. And then we talked about pluggable authentication modules. And for the applications that are PAM aware, we saw that we can change the method of the authentication used for those applications without having to do anything like modifying source code or recompiling the source code. And finally, we just talked about firewalls, and I showed you how to use IP tables and gave you some examples of simple packet filtering rules that you could use. And finally, I just wanted to say that, even if this series was 500 videos long, I know there would still be some topic that I wouldn't cover that you might want to know about. But what I've done is that I've given you enough of an exposure to Linux, and I've helped you become capable of digging up information on your own and learning about whatever aspect of Linux you want to. I really do hope you found this series informative, and thanks so much for watching.